Diode resistance. Now the topic is, for a diode, if we apply a forward biased condition with a battery, then there will be some resistance. If we apply reverse biased condition, then there will be another resistance based on the depletion region formed in the PN junction diode. Let us see in the forward biased condition, the resistance B, forward resistance of a diode. The resistance offered by the diode in the forward biased condition is called forward biased resistance. Forward resistance. The forward resistance is defined in two ways: static or DC forward resistance, capital RF, and dynamic or AC forward resistance, that is small rf. You can find this graph of VI characteristics in forward bias. This is the change in voltage from A to B voltage, and due for this change, the current change will be like this from C to D. E and F are any 2 points on the graph. O be the origin. Here my current in the diode will be milliamps, that is 10 power minus 3 amps approximately in that unit. Now let us see the static or DC forward resistance. The static resistance, since what I know, R is equals to V by I. So RF, capital RF is equals to forward DC voltage by forward DC current. That is, if we see from this graph, at point E, if I want the forward DC voltage, then it can be considered as forward DC voltage. This is my voltage 0 to A by forward DC current. That is 0 to C is my forward DC current at this point. So it is a ratio of forward DC voltage to forward DC current. We can define it as ratio of DC voltage applied across the PN junction to DC current flowing through the PN junction. We can also define it as 1 by OC by OA. That is, OA is change in voltage and OC is change in current. That is Y by X. If I want to write the resistance in terms of slope, this is Y term and this is X term. So delta Y by delta X is slope. Delta Y means OC. OC by OA. You can rearrange it as RF is equals to 1 by slope. Slope of VI characteristics will gives you static DC voltage when DC voltage is applied. If you want dynamic or AC forward resistance, the resistance offered by the PN junction under AC condition is called dynamic or AC forward resistance and is defined as small rf. The dynamic resistance is defined as a reciprocal of slope. Previously, we have seen how it becomes the reciprocal of slope. Rf is equals to dV by di, that is equals to 1 by slope of Vi characteristics. Slope is nothing but y-axis, there will be a change in current, that is di by, in x-axis dV. By rearranging it with reciprocity, it will become 1 by di by dV. So it will be Rf is equals to 1 by slope. The dynamic resistance is not a constant, but depends upon the operating voltage. From the current equation, current flow in the diode, I is equals to I naught into e power V by eta Vt minus 1. Since I want dV by di, I will do the differentiation of I with respect to V. Let us see what happens. Di by dV is equals to I naught is constant e power V by eta Vt. Since it contains V term, it acts as a variable term. So I further do differentiation for this. I'll get for V it will be 1 by eta Vt minus for constant it will be 0. Differentiation with respect to V. So from this I'll get di by dv is equals to I naught e power V by eta Vt by eta Vt. Since I know I is equals to I naught into e power V by eta Vt minus, if I multiply this I naught with this, it will become minus I naught. If I send this I naught to this side, I plus I naught is equals to I naught into e power eta Vt. I substitute that I plus I naught in place of I naught into e power V by eta Vt. Since the current through the diode is very much greater than the saturation current, so I'll consider I. Now, to find the forward dynamic resistance as Rf is equals to dV by di, that is reverse to this, that is eta Vt by I, since I naught is neglected, since it is very small when compared to I. So Rf is equals to eta Vt by I. Here you can see the dynamic resistance varies inversely with the current. At temperature, at room temperature, I know T is equals to 27 degrees Celsius. In Kelvin, it will be 300 degree Kelvin. So since Vt is equals to I know kT by U. So Q means charge of an electron, that is 1.6 into 10 power minus 19 coulomb. And substituting all the constants in the equation, then we get Vt is equals to T by 11,600. As we know, at room temperature, we know the temperature. So we can substitute the values. We get Vt as 26 millivolts. From that, Rf is equals to 26 millivolts by I is my equation. When I consider eta is equals to 1 in this equation, my resistance is in ohms when my current conduction through the diode is in milliamps. For forward resistance of 20 of current forward current 26 milliamps, the dynamic resistance is 1 ohm. That is, if I substitute 26 milliamps in place of I, then I'll get resistance as 1 ohms. So Rf is equals to delta V by delta I, that is 1 by delta I by delta V. That is one way slope of forward characteristics. General value of Rf is very small, of the order for few ohms in the operating region. Now let us see the reverse resistance of a diode. Whenever my diode is reverse biased, then the resistance obtained by the diode due to the potential barrier is called reverse resistance of a diode. You can see the VI characteristics in reverse bias, it will be like this. Again, these reverse resistance can be categorized into two types. That is static or DC reverse resistance and dynamic or AC reverse resistance. Capital RR, small rr. Capital RR is defined as, that is static or DC reverse resistance is defined as the ratio of applied DC voltage to reverse saturation current. In reverse bias, I have reverse saturation current. In forward bias, I have forward saturation current. that is from the curve at point P. How do we define? It will be defined as at point P, it will be defined as OQ. It is change in voltage by OR, that is change in current. OQ by OR. Now, if we consider the dynamic reverse resistance RR, the reverse resistance dynamic or AC reverse resistance is defined as the ratio of incremental change in the reverse voltage to the corresponding change in the reverse current. RR is equals to delta VR by delta IR. Change in reverse voltage to change in reverse current. That is all about resistance offered by the diode.